Hello, my name is Rodney Kawecki. As part of my videos for YouTube, I talk about space. In reference, I talk about the theory of relativity, as a lot of people do. But the remarkable thing about it is the idea that there does exist something that travels faster than light, which has been documented, but there has been no background advancements in the technology for faster than light speed space travel. That's the deal. And because there is no advanced theoretical literature or ideas that have advanced about this, it's not been talked about. In 1943, Edwin Hubble and Albert Einstein stood in front of a camera, the eyepiece on the Hubble telescope, and Hubble showed Einstein his discovery that the universe was expanding and space was expanding at a speed faster than light. And today we know that as Einstein's blunder. But in the 25 years between Albert Einstein's special relativity, 1915, and general relativity, 1920, 20, I think it was, everybody was already advancing on the idea about the light constant. And when Hubble came into the picture, Einstein's ideas were flourishing. And little was advanced about faster than light space, which is gravity. Gravity travels faster than light. If you want to look at it a certain way, the speed of light is slower than what gravity is. And the universe is expanding. It's getting bigger. It's evolving. It's in a process. I explained this in one of my other videos called the Black Box Universe. There's a theory called the block theory, in which is basically the same thing, that the universe and everything in it we're boxed in, can't go faster than the speed of light, and we can't travel to the speed of light. It's like a brick wall. But now we know we can. We can do this. It is possible. What I mean possible is, driving at the speed of light, is it possible? Impossible. Theoretically, yeah, because the numbers match. Can we travel faster than the speed of light? Yeah, because the numbers. How much faster can we travel? That's going to be in my next book, my next theory. How fast we can travel and why. And why do I come to these conclusions of being able to say why, or how fast we can travel in our universe, an expanding universe, one that's getting bigger. Now, the advancement of the universe is only 43 miles a second, every 3 million. I think it's 3 million miles. That's not very much. But if you look at it as a whole, it's more than expected. And that's what I do. The idea in this video is that does E equals mc squared. Under the microscope, it does when we're measuring the mass of particles, you know. But what isn't in it is matter without energy, just plain matter, which exists in space. You know, traveling at the speed of light, you can look at it two different ways. You build a ship that's capable to travel the speed of light, or you build a ship capable of traveling at the speed of light under the conditions of standard physics. Going back, it takes 2 pounds of energy to push 1 pound of mass. So, if what I was talking about in matter, or weightless mass, due to energy, the lack of energy in such a field, will travel twice the speed of light. 1 pound is reduced because the mass does no longer weigh 1 pound, it weighs 0, but it has the velocity to travel at the energy of E2, which is put the twice as much energy to push a 1 pound mass. 2 pounds of energy to push a 1 pound mass. So you take away that 1 pound mass, and it's got 2 pounds of energy, which travel faster than, it's able to push a 1 pound, but now it's going to double because you're pushing a 0 mass in space. And this is what my theories, last 4 books, and this next book, in more depth, talk about. Faster than light speed space travel. No time travel, no bending space, you know. We know space is more dense than we thought it was. So it's going to be almost impossible. It's impossible now to even think we can measuring it at light speed, you know. But going back to what I was saying, E equals mc squared, does it? Things that are under energy promote that density of energy in that field. Take away that energy and it's 0. And mass is 0. So E equals m0, mass 0, at the speed of light. Well, that means the field has to be 0. And m has to be 0, which means it's not mass anymore, it's matter. There's a difference between mass and matter. Matter at 0, they're both m, so it's kind of complicated. Both m0 is actually matter, equal to matter. Depending on that field. M0 does not measure zero in a gravitational field. It measures the content of that energy in that field. So, in my equations, what I explained to you about the propulsion value of of pushing a single pound object, it takes 2 pounds of energy to even push it, to make it move and consistently move, put it in motion. Let's say, relative to propulsion or propulsion values that we measure in space, cars, everything has to do with velocity. I'm opening up a whole new can of worms, matter without energy is matter. Let me see. Mass without energy is matter. And matter with energy is mass. So when we talk about the Big Bang, or we talk about, and I go in a different idea of what kind of eruption that was, let's say, we can visualize what happened. We have a foreign or alien mass, which they call the cosmic egg, infinitely dense. I don't think, like I talk about it in my book, but, I can say that I don't really think it's exactly like that, because I explain a lot of things about it that are not explained in your regular science, physics, the world started from nothing. I don't think that's, it started from somewhere or somehow, but let's say the cosmic egg existed. We have matter without energy, a growing state, building building up more pressure, that it became critical, and the Big Bang happened. And what happened in the Big Bang? Matter that existed at that time that caused all the pressure building up, mixed with the energy that was formed and radiation, everything in the Big Bang. So there was a physical chemistry change in the matter. Matter became mass and energy. Planets, stars, and everything that exists and we see as matter, planetary matter, celestial matter, as long as there's life, there's energy, and a physical sphere, a planet, it has a field energy. And without that field energy, matter weighs zero. Matter is empty. It's, if you ever heard of a hollow atom or the hollow moon, it's because there's no energy in it. The energy it perceives is rationalized in a multitude of everything that exists in a specific area like our solar system. Whatever keeps our solar system and galaxies that are in rotation, spinning, it keeps them in motion and in a Pacific space or area they follow. orbital track, their elliptical track. It's that barrier, or those conditions, that distance, of which magnitude is how much energy each planet has. And by each planet or star that exists, it's that amount of energy that exists. So, can energy become infinite? Sure, it can become infinite, depending on how young the energy is, how dense. They say that the space is expanding. It didn't say anything. Okay, it didn't say anything about the planets and stars, but they're getting bigger too. But not at the same rate as the universe or the planetary celestial bodies. They're expanding mobility, or whatever you want to call it, is a lot slower. And it's probably hard to measure because we live in that. We exist in that energy of the celestial body. And all of them that exist. But each energy amount in each system of stars that exist is that amount of energy at a young state, which divides something more bigger, like they said that they found a planet. What is it in another solar system that has the same exact characteristics as Earth, but and it's about 1,000 times bigger than Earth, and it's called Earth 2. And scientists believe that this is a planet we should look at, because if it's close to our planet's energy cycle or coordinate, and it's a possibility that we could travel there, journey there, live there, build stores and stuff like that. But at any rate, as you see where I'm going, it brings a different light to E equals mc squared. It has to do with how much energy exists in that confined area we're talking about, See, another story, or bull story, I was going to say, about Einstein's E equals mc squared, he also says that it doesn't matter where or what conditions. These conditions are measured the same as Earth's magnetic field as they are, or gravity field as they are in space. And those are completely different, They're two different sites. E equals m0c square depends on the gravitational energy source of the planet's atmosphere, the energy in the planet's atmosphere. And that can't correspond with something that, the scientists will say, well, there is energy, there is something in this dark, there's something. But if you notice where I'm going, where matter is matter with zero energy, in comparison with mass, which is mass and energy together, which generates a force, or a probable force, because if you have enough energy, it's going to make the other smaller entity move because of the less bound energy it's pushing against it. Energy pushes, so gravity pushes. It doesn't attract. It attracts in a similar fashion, but I think it's more repulsive than it is attraction. E equals m0q means that we are looking at the energy mass or amount of energy that exists relative to an empty space, gravity field, a field that is empty of energy. And v, which is velocity relative to c, it is no longer relative to c. V and c do not meet. V is larger than c now, with this idea of fast and light speeds, space travel, without bending space, going back in time and all that stuff. That, no, it doesn't exist anymore. I know you like it, but it doesn't. Not in this new world, So C is comparable to particle matter, or particle matter. The energy of that matter, those particles, relative to C, to where it is seated, put in motion. It depends on the amount of energy that exists in that area to correspond to how fast. You'll never, Einstein says you'll never travel, you only travel close to the speed of light. You'll never reach the speed of the light. Now we know we can travel faster than light. So what's that do to E equals mc squared? Anything? See, the complications are that Einstein took, everything, time dilation, and he took the clocks with them, and he brought them all into space where they don't belong. They only belong here on Earth. Those are effects due to the forces or interaction of forces in the planetary state, in the Earth's atmosphere. What happened there? Not out in space. See, and this is where the difficult comes in. He took all that baggage and he took it out into space. And he said, "There it is, dude." They called it a blunder, when they found out that they discovered that the Earth was expanding. They called it a blunder, but I don't think they knew exactly what it really was. It didn't only rely on how fast something can travel, but it also relied on the baggage they took into space with them, the inertia and all this stuff. And if you look at the specifics about what I'm talking about, matter in a non-energy state is just plain, it's hollow mass. That's mass without energy, which equals matter. And it's a type of matter. And we got to look at the idea of the universe is its elements or chemistry is made up of something that allows things to expand, to get bigger. We grow. We are a fast-looking yearly example of an expanding universe. We expand. We age. We get older. As When we were smaller, we were compact energy. As we grew, that energy was multiplied and multiplied and multiplied. Finally now, it ain't making it no more. It meets its criteria, and it's in content with gravitational force and that energy, and it's not going to go anymore. You know, sure, if we eat and all those things, exercise, we'll live a longer life. You know, biblical speaking, they lived 1,000 years. Do you really believe that? You got to look at the things the way they were at the time that they were done. But anyways, I just wanted to bring that into you. When we talk about E equals MC squared and all that stuff, we got MC squared, which E equals is E with G. You know, and mass zero is equal to matter without energy. And the speed of light is slow. And if you want to read about it, you got to be away from my next book. You could read my other books. What I read, told you here, they're within that content of what I'm saying. You know, relative to being there at the time. You know, at the time, this is what we believe. This is what it is, and this is what we've been doing. You know, but you got to take those steps backwards. You know, there's no time travel anymore. You know, the idea of time travel is in the far future. It's like if time travel is discovered in 50,000 A.D., which is after Christ, it would actually be 100,000 years from now. You know, it's we don't. Well, I wouldn't say it's that far. Intelligence is pretty quick. You know, expansion is pretty quick. Making things clear is faster. Is a development the same as anything else? Everything else, your consciousness, everything. Expansion. You live in a dense field. It's harder to. It's easier to recognize, but it's harder to visualize. Let's say, you know, there's always some contradicting force acting within our thinking as well as our universe as a materialistic entity as a whole. Anyways, my name is Rodney Kawecki, and I hope you like my videos, and I hope you can understand a little more about the universe. Thank you.